Hello everyone, welcome to AI Anytime channel. In this video, we are going to explore mergekit. So we'll see how we can, merge multiple large language models and we'll create a mixture of experts model. Not a new terminology when it comes to generative AI ecosystem. Mergekit has been famous, got all the attention because of Mixtral model, which was a mixture of experts model. You would heard about ATEC 7B model, okay, where they have multiple LLMs working in tandem, and that's basically an experts mixture of experts model. We'll see how we can do it. Ourselves, how we can create a mixture of experts LLM using mergekit. So mergekit, it's like a toolkit, and you'll see the word kit which is there. So it's a toolkit basically that helps you, merge multiple LLMs. I will not go too detail into algorithms on how the slurp works and how this merging algorithm works. We'll just see how we can use this library to basically merge multiple large language models. The overall agenda here of the in this video is to take medical specific LLM. We're talking about medical domain, and we'll see how we can merge two or three medical related LLMs and create a mixture of experts. So let's do that here. Now, if you look at on my screen, I'm currently using RunPod, but you can also do it on Colab Pro. But to do this, you need 800 GPU. So if you just want to follow along what I am doing, you need the A100 GPU to work with. I don't trust Google Colab Pro for A100. They don't have that always available. They always migrate to or transform to V100, which I really don't like. So I am using RunPod here. You can see I have set up RunPod, and then I am just using as inside a notebook. Now here is the merge kit GitHub repository because we have to clone that. So first thing that we're gonna do is we're gonna copy this thingy here. So let's just copy git clone, come over here, and then just do git clone. And then I'm just gonna do -b. Let's create something. So I'm gonna call mixtral and then just clone the repository. So this is what I'm gonna clone. And then you just don't need git clone again. I'm just gonna remove this HTTPS and then just cloning into it. Now guys, A100 is the most used GPU. If you are working with large language model, I recommend using the Ampere architectures. Of course, not only A100, there are other Ampere architectures of GPU that you should always use when you work with large language model for the pre-training or fine-tuning purposes. Now, on RunPod, it's 1.89, less than $2 per hour, which is really affordable. So now next, you can see that we have merge kit cloned over here inside this folder called merge kit that you see. Let me just double click here and you can find out everything which is required. So I'll just go back to workspace now, and yeah, I'll just make it a bit bigger. Okay, cool. And I can just make this a bit bigger so you can just see this. Okay. Now git clone, this is done. Now let's go cd into it. So what I'm going to do is cd merge kit, and once I do cd merge kit, I also want to install whatever the required dependencies for merge kit. So pip install, and then you just do -e because there's a requirement file inside merge kit folder directory whatever, and then just dot means that in the same folder you have a file of requirements txt, and let's just do that. So what I'm going to do, we are going into that merge kit. You can see it's installing build dependencies and things like that. Now, this will take a bit of time because there are few libraries packages that it has to install. So let's wait for that. Meanwhile, we'll write our next piece of code, which is uh, upgrading the transformer. So let's do that. So for that, what I'm going to do is pip install, and then I'm going to upgrade. So hyphen upgrade, and then you just do transformers. That's what I'm going to do here. And if it has the latest version, it will be completely fine. And you can see this has been done. Now, after that, what we're going to do is we're going to basically create a config file. This is how it works. You have to create a config, and so I have saved a GitHub gist, and I'm just going to use that. So let me just do that here. I'm going to open my GitHub. You can see AI anytime, and Guys, we have recently reached 1K followers on GitHub. Thank you so much for following the GitHub repository as well. We have more than 200 repositories, as you can see. We have a lot of open source project that you can leverage for your projects, your hobby projects, or your proof of concepts and things like that. Now in just let me just bring up my monitor here. Yeah. Okay. Now we have this config that you see. This is not the config, these are the configuration for the LLMs, and I'll show you what I'm talking about. Let me just go raw and get this from Control A, Control C, and come over here and then paste that. Now, if you look at the merge config, and they will add few more cells from here. I'm adding few more cells. Now, the base model, so when you create config, so merge, if you want to use merge kit tool to merge multiple large language model, you need a base model and you need an experts model, right? That's what we are, which we have specified here. Now base model is the biomistral 7b, so that is our base model, which is one of the best medical specific model in the 7 billion weights category. That's our base model. And then we have experts model. I'll cover D type and get mode later. Experts, we have two models. You can have n numbers of models, but keep in mind that if you increase the number of model, you need more space, when you need more compute, okay, to do that. Now we have a base model which is biomistral 7b, and then we have couple of source model as an expert. One is Meditron, so I'm also looking at Meditron 7b, and then you can give positive prompts and negative prompts. So in positive prompts, I'm saying you are a not an helpful, so you are a helpful medical assistant. And then in the medical NER, I'm writing you are helpful assistant for medical entity recognition, medical, and I'll call it named entity recognition. Okay, you are, I'll remove the helpful, I'll call it you are assistant for medical named entity recognition. So if you want to find out more about these models, what you can do, you can also search on here Hugging Face Spaces. You can come here, you can see Meditron. It was you can see medical domain from llama 27b, blah blah blah. So this is the model we have. So Meditron has been fine-tuned using PubMed Central. So PubMed Central is a biomedical literature repository where they fine-tune llama to on those pre-processed data and things like that, and then they created Meditron with some different way of fine-tuning that they have of course listed over here. You can see continued pre-training on a comprehensively curated medical corpus, right? So this is why we have taken Meditron 7b. Our base model is biomistral, and then we have medical NER. So I need, I'm looking at some creativeness here from a use cases standpoint, because named entity recognition will be very helpful if you want to build if you want to extract tags, or if you want to extract keywords from a medical text corpus. For example, if you work with medical notes, you work with synopsis and things like that in medical domain, medical workflow or administrative job, how can you use these models to basically amplify your workflow, right? That's the reason. Now let me just yeah, now let's talk about the D type and your get more. Now D type float 16, it's a data type that basically used for storing and manipulating numbers. Let's talk in layman terms, guys. You talk about float 16. It basically helps you with the floating point numbers. In neural networks or any kind of computational task that you do. It's a 16-bit floating point data type. Okay, that's called float 16. We have float 32, we have float 64, and things like that. Now, here we are talking about float 16. It's also being called as half precision floating point. So it's half precision floating point. Basically it used to reduce the memory footprint of whatever models that you've been working with, and it can also speed up the computation. That's why we use float 16. There are other pros as well of using float 16, but there are cons as well. Now cheap embed that you see, it's basically we are looking at this is an optimization technique for to make embedding operations more efficient when the slurp algorithm that we have been using, or the techniques for merging. So you can look at different parameters which is available in merge kit if you want to really go a bit deeper on a comprehensive merging of LLMs, you might need to understand these things a bit better. But this is not the scope for this video. So now if you look at here, what I'm going to do next is I'm going to write this in a config file. So I'm going to say uh, with open, and it's a function. So let's here write config.yaml. So you create a YAML file and then you just save it over here, write it over here, and then you say as file. Basically what we are doing here is we are writing the config.yaml. Now this config.yaml will contain this above defined merge configuration. That's what we're going to write here. And I'm going to say f.write, and let's just write that. So I'm going to do merge underscore config, and let's run it. Now once we run that, I hope I've run it. Yeah, you can see that we have a config YAML. Once you double click it, this is your config. Okay, so what I'm going to do is I'm just going to save this again here, this config file, and you can create separately. Now, I already have a video, guys, with stable diffusion MOEs, which was by SegMind. So we have created a video already for merging stable diffusion models. Here we are doing for large language model, which are mainly for causal modeling, which are for text generation. If you are interested in watching how to merge stable diffusion models, I will give the video link in description. You can have a look at that as well. Now, once this is done, what we're going to do next is we're going to run the command. So what I'm going to do, merge and kit MOE, and I'm going to write config.yaml, and then merge, and then I'm going to write copy tokenizer, and you can pass a lot of args here, copy tokenizer, and I can also have allow. uh, and this you can also get it, guys, from their GitHub, if I am not wrong, right? If you see, this is this is how you can also use it. This is how they say lazy unpickling, allow crimes, blah blah blah, right? There you can just find it out over here as well. Now allow crimes, and then you do an output. So basically that's called out, and we're gonna have a sard size of, for example, let's have a 1b, and then I'm gonna have lazy unpickling. So lazy, and then you just do unpickle, and then you just write trust remote code. Is keep in mind that this merging can happen on CPU as well, but then you have to download this weights and other files, right? That for that you need volume, you need a huge amount of volume to do that. So merge kit MOE config YAML, and then we are saying merge, and then we are passing copy tokenizer, and then allow crimes, and then output sard size 1b, and then lazy unpickle, and then trust remote code. That's what we are doing here. Let's run this. Now, once you run it, guys, it will take a lot of time to do that. So what I'm going to do here is I'm going to pause the video and come back once this step is done. As you can see, guys, our merge has been completed. You see fetching 7 files, export prompts, and we have a merge folder. Now, if you go inside merge folder, you will find all the merge things. So it took around 10 to 15 minutes, to merge, because we have merged two models with the base model. So, and that's what it is. So what I'm going to do now is I'm going to, and you can see I have written some code just to save some time, but I explain that right now. Here I'm using Hugging Face Hub import HF API because we have to push this merged model to Hugging Face so we can later use it in our use cases, right? Whenever you want to use that. Now you can see this is my username. This is, and of course I will delete the key. This is just I created it for this video, and then I'm naming my model name as Medpaxtral 2x7b, right? So we are, using Meditron, Mistral models, and we are merging it together. It's the 7b model, and that's why we're calling it 2x7b. If you want more models, you can, the numbers will have to be relevant there. If you have 4 experts model, then it will be 4x7b if the weights categories are 7b. But if you are looking at 13b or 70b models, if you have that compute, that will go the name will change, right? So I am calling it Medpaxtral 2x7b. Now what I'm doing, I'm using Hugging Face API, and I'm saying create the repository first. So if you look at here, there is not such repository. It will create a new repository on my Hugging Face space here, and I'll just go back here, and I'm calling it username slash model name repo type model, and this is my local folder merge from where I am pushing this to Hugging Face. So let's push that. Okay, and I'm going to push that. I already had done it, but I'm showing you that how you can do it again right now. Once you Push it to Hugging Face. This might take few minutes because you have a lot of LFS, large file. It has to go through Git, and you have to upload this large file that might take up to 5 to 10 minutes, I believe, right? So let's wait for that, and you can see it's pushing it. And once it put, I'll probably write the code that how you can do the inference, guys, and if you want to inference it as well, or probably we can also uh, let me just plug my charger. Okay, now you can load this in 4-bit, 8-bit, however you want to load that. Okay, now I believe we need a transformer, we need accelerate, and we need those things. So let me just write the model, and probably I'm gonna call this new model, and new model, and then you write your whatever model. So repository would have been created by now. If I just do a refresh, you will see there is a new repository. Oh, hold on, why did it call med medpackstral 4x7b? Are we? But this is, I renamed to 2x7b, but whatever. So let's wait for that. And let me write the code for you. So maybe you can just have an understanding of that. Okay, now, for example, if this is what it is, I'll just copy here, paste, and this is how you define it. Now this becomes your new model, and then you can then have the tokenizer, the way you load from pre-trained, right? So auto tokenizer and auto tokenizer dot from underscore pre-trained, and then you can just pass the model, new model, by the way, new model that we have, and then tokenizer is done. Then you can create a transformers pipeline, so you can get it through transformers pipeline, and you can also get three causal LM. So for now, let's get three pipeline equals transformers dot pipeline, transformers.pipeline, and here you can just define a few things. So the first thing that you're going to define is that's the text generation task. So let's define the task. So this is text generation. This is not a mask language modeling. This is a text generation, and then you can write model equals, which is new model that we have named it above, and then you can give model quark. So let's give that here, and then I'm going to give the torch d type. So let me just give torch d type equals, you give not equals, by the way, these are key value pairs. So this goes like torch.float 16, and then you also define load in 4-bit. So let's use bits and bytes. So load in 4-bit, and then this goes as true. It's a boolean value, so let's make that true. Now this is how you do the model quarks, by the way. Now this pipeline is ready. Once pipeline is ready, what you're gonna do is you're gonna give us a simple system prompt or things like that. So let's do messages equals, and then it's a list inside a dix, and then the dictionary inside it, and then here you can write to role, and then you can write user, and then you're gonna write content, and then you can write, for example, uh, do you know how to write a medical note looking at, okay, let's ask how to write a medical note. Okay, this is what I'm asking here. And yeah, and this is messages are done. Now then you have prompt equals, and then you're gonna pass prompt pipeline dot tokenizer dot apply underscore, I'm gonna use apply underscore chat template, and I'm gonna pass messages tokenizer equals false, and add generation prompt, and then it goes true. It's a boolean value. Now I hope I have, okay, I haven't closed it yet. Okay, now this looks nice. So we have pipeline.tokenizer.apply chat template. Now let's get the output thingy. So I'm gonna have output equals pipeline. Okay, so pipeline, and then I'm gonna pass my prompt. Inside this, I'm gonna pass, let's have a small new tokens, not more than, for example, just for testing, 256, and then do sample true, true, do sample true, and then I'm gonna give temperature. Let's keep 0 0.7 is a good temperature for this kind of questions, and then I'm gonna write some other inference parameter, top k, top p, the standard one 0.95, and this makes sense. Now we can just print the outputs. This is how our outputs looks like, and excuse me, and then I'm gonna write generated underscore text. This makes sense. Okay. Now this is how you can run this, but I'm just thinking, why did it call it metextual 4x7b? Because I have name, probably I didn't run this. Yeah, for now let's use that. I mean, I can anyway change that. That's not a problem. Okay. So guys, this will take a bit of time, but I'm not gonna run this because then again I have to download the model again. You have to guys have to wait. But this is how you can inference it. Here, this is the merged model that you see that has been pushed on Hugging Face, and you can use this code to do inference. That's how you're gonna do inference and see if this is, this is able to do the job that we wanted the model to do. Right now, that's why this is important, guys, to merge LLMs only when you think that the base model is not able to do the task, right? There's not much of difference. Even if you look at the evaluation benchmarks, there are 1 or 2% or even less than that are the differences on that too, not on all the benchmarks, but a few of the benchmarks. So it doesn't make sense to burn the compute power, memory, money, and things like that, right? There will always be performance trade-offs. But in a case where you have a very unique use case where these LLMs are struggling, and then you think that combining multiple LLMs might make sense, then only you go and merge LLMs. Not only because somebody else is doing in the industry, then you also have to do that. That's what I wanted to create in this video, guys. I wanted to help you guys to see how you can take a A100 GPU and merge multiple LLMs and push it to Hugging Face. This notebook will be available on GitHub repository. If you have any question, thoughts, or feedbacks, please let me know in the comment box. And if you like the content I am creating, please hit the like icon. And if you haven't subscribed the channel yet, please do subscribe the channel. If you want to reach out to me, you can also reach out to me through my social media channels. Please find those details on channel banner and channel about us. Thank you so much for watching. See you in the next one.